Welcome to module 14.5, simplifying complex expressions. So, what is so-called a complex expression? What is so-called a complex expression is basically, or complex fractions, is simply a fraction over another fraction. All right, that's what the complex fraction means. Now, there are two methods of simplifying complex fractions. So in this lecture video, I'm going to show you how to simplify complex fractions by simplifying the numerator and the denominator and then divide. So basically what's going to happen here in this particular technique is make sure the numerator only consists of one fraction or one term. Okay, and then we're going to simplify our denominator, okay, and make sure it's going to be one term. So once we are one term over one term, then we can divide. So with this problem, for example, I want you to take a look at this fraction bar right here. So that fraction bar is going to be the last thing we're going to take a look at. So basically make sure above that one is one term. Below it, denominator is also one term. So once you are one term over one term, then we can divide, which is my red fraction bar. So basically this problem, I'm going to take the top, 5x squared over 2y to the third, and then divided by, okay, let me put that in red so we know, and then divided by the denominator, which is also one term, 3x over 5y squared. So this is a division of a fraction. So that means we will times the reciprocal. The first term stays the same. First fraction stays the same, times the reciprocal, which is 5y squared over 3x. All right, since every numerator and denominator is one term over one term already, so I don't have to do any factoring. So I'm just going to cancel out the common factor. So let's see what I end up with here. I got 2x on top, we cancel out with 1x in the bottom, so that'll leave me with 1x on top. I got 2y on top, cancel out with 3y in the bottom, so that'll leave me with 1y in the bottom. The 5 and 5 on the top can now reduce with 2 and 3 in the bottom, so let's multiply side by side, which is 25 over 6. So my answer, 25x over 6y. All right, so same thing. Watch out, this fraction bar right here, that's my division. I'm going to do last. So above it, my 5 is one term, but my denominator is not quite one term yet. So let's make sure, okay, the denominator, which is two terms, let's make that into one term first. So let's do this on the side. So the denominator is addition of rational expressions. So let's find our LCD. The LCD between x to the third and y to the third got to be x to the third, y to the third. And here's the reason why. The first denominator is x to the third, which is x times x times x. The y to the third is basically y times y times y. So when it comes to finding LCD, none of the factors repeated between the two denominators. So we still have to count. Okay, we still have to count every one of these one time. So that's why it's still going to be x to the third, y to the third. All right, so x to the third go into x to the third, y to the third, got to increase. Okay, got to increase y to the third times. So basically, what does my first denominator has that what does LCD has that my first denominator do not have, which is missing the y to the third. So we take that y to the third times my numerator, which is 4y to the third, plus what does the LCD has that my second denominator do not have? My second denominator is missing that x to the third, so we take that times by the 1. So basically my numerator is simply 4y to the third plus x to the third over the LCD x to the third y to the third. So now let's take the 5 divided by the denominator. Division of a fraction means times the reciprocal. So that means my denominator here will flip, which will give me x to the third y to the third over 4y to the third plus x to the third. All right, so since the 4y to the third plus x to the third, there's nothing to factor out to reduce with anybody up here, then we can just multiply side by side. So that's 5x to the third y to the third over 4y to the third plus x to the third. All right, that would be my answer. So make sure if my numerator over denominator originally is multiple term, make sure we add them or subtract them to make them into one term over one term before we divide. All right, so let's take a look at this one. Right above this fraction bar, that's already one term. It's a denominator we got to make it into one term. So let's take a look at that real quick. So I'm going to write x over x minus 2 over, let's see what we're going to end up. All right, 3 over x minus 2 plus 1 over x minus 3. The LCD, since I cannot, there's nothing to factor for the x minus 2, then we would just, so that we would just put them in the parenthesis to indicating I'm factor out a 1. So for the x minus 3, same thing. There's nothing I can factor out other than 1. So when it comes to counting the LCD, none of the factor repeated, so we got to count both of them one time. So my LCD, x minus 2 times x minus 3. So my first denominator is missing the x minus 3, so we will take that times my numerator plus 1 times. My second denominator, x minus 3, is missing the other x minus 2 as compared to the LCD. So that we will take that, x minus 2 times the numerator. All right, so let's simplify this. Okay, I'm going to do it right here. 3 do a distribution, that will be 3x minus 9. Positive 1 do a distribution, that's positive x, negative 2. If I combine like terms, that will give me 4x minus 11, which cannot be factored other than 1 to cancel with the denominator. So we're just going to keep it like that. So my numerator is now going to divide it by 4x minus 11 over x minus 2 times x minus 3. All right, so x over, okay, this x minus 2 is 2 terms. Nothing can be factored out other than 1, so I will put them in the parenthesis. All right, division of a fraction means times the reciprocal. So this x minus 2, x minus 3 will flip it to the top. 4x minus 11, nothing can be factored out other than 1, so we will put it in the parenthesis. Okay, so I'm basically factoring them as I flip them, just like I done in the previous videos. So the only common factor top and bottom can be reduced is actually the x minus 2. So this x is still x times x minus 3 on the top over 4x minus 11. All right, so since there's no other factors in front of the parenthesis for the 4x minus 11, I just take it off. I don't really have to have it. So that's my answer. Okay, simplifying our complex fractions. All right, let's try it one more time. Okay, this division, this is the fraction bar for the division of top and bottom. So let's take a look. For the top, that's subtraction. Let's make it one term first. So that's 6 over x plus 6 minus 1 over x plus 4. So since both denominator cannot be factored other than 1, then when I count the LCD, each one of these will be counted one time. So that's my LCD. Plus 6 plus 4. All right. What does the LCD has that my first denominator do not have, which is the x minus 4? We take that times my numerator 6 minus 1 times. My second denominator x plus 4 is missing the x plus 6, so the x plus 4 will go into the LCD x plus 6 times. We take that x plus 6 times the numerator negative 1. All right, so let's simplify this real quick. Distribution is 6x minus 24 minus x minus 6. Let's see, 6x minus x is 5x. Negative 24 minus 6 is negative 30. So here I can factor out a 5. All right, so let's do it over here, okay? So the top is going to divide it by the bottom. So that's factor out a 5 at the same time. That's 5 times x minus 6 over the x plus 6, x minus 4. I don't know, do I really need to factor out that 5? I don't know until I factor it and take a look. Divided by the x plus 7, two terms that cannot be factored other than 1. So let's divide it by x plus 7. Let's put that in the parenthesis. And that x plus 7 being divided is over 1. So division of a fraction means we will times the reciprocal. So that's 5 times x minus 6 over plus 6 minus 4 times the reciprocal. That will be 1 over x plus 7. So as far as top and bottom, numerator and denominator being canceled out, there's no common factor. Okay, so we'll just write everything out together. So the numerator would just now be 5 times x minus 6 over denominator plus 6 minus 4 and plus 7. Okay, that's all it is. All right, so this particular technique sometimes it's very easy to use, sometimes it's more cumbersome. It really depends the nature of the problem itself. But basically, we want to make the numerator and the denominator one term over one term before we take on the division. And then once we take on division, then it becomes multiplication of the reciprocal. All right. In the next lecture video, I will show you another technique that is actually more popular to use. So that will conclude this lecture video. Thank you for watching.